Okay, let's take the story forward in our introduction to the subject of thermodynamics and propulsion. In the last module, we studied or got introduced to the basic preliminaries of thermodynamics. Today's we're going to look at propulsion side. In this course, I look at thermodynamics and propulsion as equally important, 50-50. We learn thermodynamics to take it forward to propulsion and engines. Let us start with the internal combustion engine. The simplest picture of an internal combustion engine possibly is this one, where we have a sorry we have a cylinder fitted with a piston and filled with a gas. For us, it will be mostly air, and this is our working fluid as we defined in the previous lecture. The piston is fitted with a mechanical arrangement, a crankshaft, which converts the motion, which is linear motion of the piston, to the circular motion, which is useful to drive a wheel, for example. The first step, once we have air in a piston cylinder, is to move the piston in and compress the air. And by doing that, we are increasing pressure and temperature of the gas. That's the first step, compression. After that, once we have air at relatively high pressure and temperature, we inject fuel. Through this small passage that is shown in the top. In fact, fuel is mostly in liquid form. It involves quite a few steps of make it into small droplets, vaporizing it, and then burning. We ignite it. And this process, in technical terms, is called combustion. So this is the second step in our IC engine after compression. And once we burn the fuel, what we have is the temperature and pressure of the air shoots up. We have a highly energetic let me call it a gas, because it has maybe combustion products also naturally. So this high energy gas is now trapped inside the cylinder, and what do you do with it? We make it do our work. We make it push the piston out of the cylinder. By doing that, by pushing the piston, it is generating work. And that drives a wheel, for example, of an automobile. Where this hot gas, high temperature, high pressure burned gas, or post combustion gas as it is called, it pushes the piston out, it goes to a lower pressure and temperature, and this process is called expansion. So this is the third step of our engine function: compression, combustion, expansion. So let's put the three things together side by side. It's the same piston cylinder for now, which I showed earlier. First going through compression, then combustion, expansion. Notice the direction of the piston is shown by this arrow, and the direction of the wheel or the crankshaft is shown by this. So you can make out when the crankshaft moves in such a way that the compression happens, and then combustion, and finally expansion when the wheel completes its one turn. This crankshaft completes its one turn. There are a set of valves on the top because at the end of these three steps the gas is all burnt out. We can't burn any more fuel so easily, so it has to be ejected. So one of these valves will open and the gas goes out. Then this other valve opens to let in fresh air. Exhaust and inlet valves are shown here, and this process repeats over and over, and there's continuous work generation. Also, what we should know is that most of the time when we have, let's say, look at a car engine, there are more than one cylinder. There are 4, 6 cylinder engines. So these cylinders are stacked side by side in such a way that when one of them piston is going up, the other one is going down. So we have actually one of the engine cylinder piston is driving the compression of the other. So work is generated only in the expansion stroke, but that expansion stroke of one cylinder drives the compression of the second, and then when that expands, that drives the compression of the third, and so on and so forth. So this kind of arrangement is very common in automobiles, cars, trucks, even motorbikes, everywhere. Small aircrafts, which are called general aviation aircrafts, 2-seater, 4-seater, 6-seater, small aircrafts use internal combustion engines. In fact, these IC engines are used many places. Examples include boats, even lawnmower, and several other examples can be written down. But I think IC engines are present in many scenarios, and they all function the same way pretty much. The configurations might be, orientation may be different, but they work in the same way. And the three main steps are compression, combustion, expansion. Expansion is the work generating step, and combustion is the heat input step. And we will go over these thermodynamically when we come to analyze these engines. But before that, let me say one thing, that this piston cylinder, which is inherent in a IC engine, was also the same piston cylinder arrangement which was used in the first engine, the steam engine. We will look at that also. So piston cylinder is I think of it as ubiquitous. It's all over the place when we study thermodynamics. So you will see me draw a piston cylinder in very simple terms in this way, and you may want to learn to draw it in your own way and make quick drawings when it comes to exams and problem solving. This is my cylinder. Draw a piston. Show the shaft. Sorry, not that good, but still, shaft moves, the piston moves in and out. There is a gas filled in the cylinder piston, and there goes my IC engine picture. It is very useful to understand many basic concepts, especially when we look at systems approach of thermodynamics, and we will use this piston cylinder over and over again. What I would like you to do is to go to the internet and look at a video animation which is very interesting to see, and shows the internal working of the IC engine, and shows all different parts, how they come together at this link. It will kind of explain what we had talked about in terms of schematic. It will show it in a much more realistic picture. It's good to have that physical picture when we start going into analyzing and doing calculations, thermodynamic calculations of these engines.